Hey guys, so in the last lecture we have seen an example of a simple pendulum, and also we have seen various springs in series and springs in parallel. So today we will see one more example to find the natural frequency. So if such diagram is given, that we need to find the natural frequency of the system. Now if we see what is given in this diagram, so here here in the question, a semicircular disk of radius small r is attached to a fixed support from the center of the diameter. So, and this disk is oscillating from left to right with respect to the center of this diameter of the semicircle. So suppose this semicircular disk is having a center of gravity G. Now the distance between the center of the rotation and the center of gravity is given, that is G. It is 4r by 3 pi. But in certain cases in exam, if it is not given, then we need to calculate, or we need to know this by our own, the value of the semicircular disk from the distance from the center to the center of gravity of the semicircular disk. Now, what will happen that, as we have seen in pendulum, this is similar to the pendulum. So in pendulum, as it was oscillating, so this disc will also oscillate from left to right. So let's take a case. So I have drawn here. So suppose this disc is rotating. So what all forces will this have disc? This will have. So first, oh sorry. So the first will be the weight, that is mg. So according to Newton's law, when this disk is when this disk is stationary, so an equal and opposite force would be acting in upward direction to counter this weight. So that force will be uh, will be accounted by the this fixed support. So if now the disk is oscillating, so similarly we will see, so the weight is acting in downward direction. So let's split the terms in x and y direction. So here it will be w cos theta, and here it will be w sin theta. So similarly here the w cos theta will be uh, will be equal out it will be equal out with the force of the fixed support. But here the w sin theta, so w sin theta, so this force w sin theta will be reacting with this fixed support. So this will be also be equaled out with the help of fixed support. But a torque is generated due to this change in the action of the force. So that is w sin theta into this distance. So what is this distance? So this distance is nothing but 4r by 3 pi. So this torque, that is h, so that torque is w sin theta into, it is 4r by 3 pi. So let's call 4r by 3 pi as some constant. Let's call this 4r by 3 pi as L. So this force is this torque is balanced with the help of an inertia torque, that is I theta double dot. So suppose if we are taking the left as a negative, So if we are taking this left as negative, so on the right as positive, so this torque will be I theta double dot. So the same formula, this is for the pendulum which we got, so here the same formula we will use here. So uh, let's let's use, so I theta double dot plus W sine theta L is equal to 0. Now as we know that when theta is very small, so when theta is very small, so what we can take, that sine theta is equal to theta. So and here also we will put the value of L. So what is the value of L here? So that is 4r by 3 pi. So we'll keep afterwards. So I theta double dot plus W is m into g into theta into L is equal to 0. So theta double dot plus, let's divide the whole equation by I. So upon I, theta is equal to 0. So if we compare it with this SHM equation, so we have got the natural frequency of the system, that is omega n is equal to under root mgl by I. So this is the same equation which we got in the pendulum, but what is the difference here? The value of L. So the value of L is here different. So here, so m g L. So what is the value of L? So L is 4r by 3 pi. And what is the value of moment of inertia? So here moment of inertia is mr square. Mr square. So gets cancelled. So that is r gets cancelled. So we've got omega n is equal to 4g by 3 pi r. So we've got this moment of inertia, sorry, natural frequencies equation. It is 4g by 3 pi r. So this is the natural frequency of the given system. So now similarly we will see one another example. So example number 3. A semicircular disk is lying on a flat surface. Semicircular disk is lying on a flat surface having radius r and center of gravity is g, and we know the distance between this and this is 4r by 3 pi. Okay, so this we need to remember, it will not be given in each and every question. So we need to find the natural frequency of the given system. So now here similarly we will draw the diagram when it is oscillating. So let's draw the center line first. Let's take the center point first. It's not a good diagram, I guess. So let's draw the oscillating diagram. So similarly here, this is the center of gravity is G, the center of oscillation is O, and here the distance between from the center of the oscillation and the center of gravity here, suppose if we are taking it as x, so here similarly we will use the Newton's equations. So here similarly the weight is acting in downward direction, that is mg, and similarly so it will give two components, mg cos theta and mg sin theta, in two directions, and similarly it will generate a torque in opposite direction, that is I theta double dot. So I will write directly the equation, that is I theta double dot plus mgx. So here we need to understand one thing, that the force, the balance force acting on this circular disc is due to the support of this, the support on the ground. So the forces acting on this disc to balance the weight will be acting from this direction. So it will be acting at this direction. So the distance between the center of gravity and the central axis, so this distance this time we need to find, and not this distance. So here the distance will be mgx, so that is mgx is equal to 0. So this time the forces are acting from the downward direction, and not as in the case of pendulum or in the case of last example. So here the formula will be I theta double dot plus mgx is equal to 0. So now what is x? Now as we know that this here this will form a triangle. So let's form a triangle. So this is x, as we know that this is 90-degree angle, and this length we know that this is 4r by 3 pi. This is 4r by 3 pi, and this angle is theta. So now if I want to find x, so what will be the value of x? So let's take sine theta. So sine theta will be x upon hypotenuse, that is perpendicular upon a hypotenuse, that is x upon 4r by 3 pi. So what will be the x value? So x value will be sine theta into 4r by 3 pi. So I theta double dot plus mg into 4r by 3 pi into sine theta. But as we know that as theta is very small, so sine theta will be equal to theta. Okay, so sine theta is equal to theta because theta is small. So now let's again divide the equation with respect to I. So we got theta double dot is equal to mg upon I into 4r by 3 pi into theta is equal to 0. Now similarly if we compare this equation with our our SHM equation, simple harmonic motion equation, so we will get the value of natural frequency omega n is equal to under root mg 4r by 3 pi upon I. Now here the most important thing, that moment of inertia I. What is this I? So this is moment of inertia at the ground. So let's at the pole, at the surface, so let's say this I, that is is, so this I is nothing but is. So we need to find the moment of inertia of this surface. So how we can find the moment of inertia at this surface? So to find the moment of inertia at this surface, so what we know, so which moment of inertia do we know? So we know the moment of inertia at the center, that is IO. So IO we know. So the moment of inertia at the center IO, that is m mr square. So the moment of inertia at the center will be mr square, but at it is a semicircular disk, so it will be mr square by 2. So the same thing also we need to we need to apply in the last example also. So here, as it was a semicircular disk, so here we have taken moment of inertia as mr square. So it was actually mr square by 2. So the answer will be 8g by 3 pi r. So for semicircular disk we need to divide by 2. So if it is a full circular disk, then it is mr square. So this is mr square by 2. Now if we use the parallel axis theorem, so what is the distance between this O and G, that we know, that is 4r by 3 pi. So let's say the distance between them, that 4r by 3 pi is h. So if I want to find the moment of inertia at G, then what it will be, that as we know that IO is equal to IG plus mh square. So I want to find G, so it will be IG plus IO minus mh square. So we want to find the moment of inertia at the surface. So why we are finding at the center of gravity? Because this will help in finding the moment of inertia at the surface. So Ig will be equal to IO. IO is m r square by 2 minus mh square by 2. Now what is h? So h is 4r by 3 pi. So let's take m as common. So what we are left with? Mr square is common, so we are left with 1 by 2 minus that is uh, what we are left with, 16, 4 4 just 16 by 9 pi square. So 4 4 just 16, 3 3 9 and pi square, 16 by 9 pi square. So this is the moment of inertia at the center of gravity. Now we will use again parallel axis theorem, that is IP is equal to IG plus mh2 square. Now this h2, what is this? The distance between the surface, sorry, the distance between the surface and the center of gravity, this distance. The total distance is radius r, and this distance is 4r by 3 pi. So if I subtract the if I subtract r from this distance, so we'll get this distance. So we will see that is, not p, sorry, I surface is equal to, so I surface will be equal to Ig. So I'm not putting the values, just denoting it into what will be the h2. So h will be r minus 4r by 3 pi whole square. This is r minus 4r by 3 pi whole square. And what will be the Ig value? So Ig is this value, mr square, and this. So we need to expand this equation. So before expanding, let's take the r is common, so m, let's take r square common, so we are left with 1 minus 4 by 3 pi, 4 by 3 pi whole square. So 4 by 3 pi whole square. So let's move ahead. So here now we can keep the value of ig. What is the value of ig? So that is mr square. So I can take mr square from both the sides common, so this mr square and this mr square. So we are left with 1 by 2 minus 16 by 9 pi square, plus I'm left with 3 pi minus, so I need to, so I will apply the formula for a minus b whole square. So that is a square plus b square, 4 4 just 16 by 9 pi square, okay, minus 2 into a into b, 4 by 3 pi. So here the 16 by 9 pi square will get cancelled, and what we're left with is mr square into 1 by 2 plus 1, so it will be 3 by 2 minus 4 to the 8 by 3 pi. So let's take LCM. So we will get, so for LCM we need to multiply this by 3. So 3 3 ja, we need to multiply by 3 pi, 3 3 ja 9 pi, and this we need to multiply it by 2. So it 2 ja 16 by 3 pi. So this is the moment of inertia of the surface. So our formula for natural frequency will be omega n. So what was our formula? So formula was mg, so we will put the value of moment of inertia here, so sorry here, so that is mg 4r by 3 pi into is. So that is omega n was equal to under root 4r by 3 pi into mg upon is. So let's put the value of is. So 4r by 3 pi into mg upon is. So is is mr square, into 9 pi minus 16 divided by 3 pi. So 3 pi will get cancelled, r will get cancelled, m will get cancelled. So we are left with sorry, here 3 2 ja 6, so here the value was 6 not 3, so I will just change it. So here the value was 6 LCM, so 3 pi into 2 was 6, so it was 6 pi, so here it was 6 pi. So here 3 pi and here you will get 2, so the value will be under root 8, 4 to the 8, and g, we are left with g and below r into 1 upon 9 pi minus 16. So this is the value of natural frequency of this system. So I hope you understood. This example. So these are the examples which are asked in exam to find the natural frequency of any given system. So we will see few more example if time permits. So otherwise we will start with next topic. So thank you very much.